When we start getting into equations, we start with the most basic ones. First of all, just what is an equation? And it's a statement of equality. And that's the most important part of an equation, is that it's a statement of equality between two expressions. So when you look at a mathematical statement, if it's an equation, it would have an equal sign because of the equality. Two things have to be equal. Now, if it's a linear equation, then we start talking about more of the specific characteristics of what we see in the equation. Not just the equal sign making an equation, but to make it linear, it can be written in the form of ax plus b equals 0. Meaning that a and b can be any numbers we want, positive or negative, decimals, fractions, roots, it doesn't matter. But the thing is that we only have one variable, that being x, or another variable letter like n or a or whatever, it doesn't matter. There's only one variable and it's only raised to the first power. That's the most important thing. Now when it comes to a solution, and this is a very general definition of a solution that doesn't just work for equations or linear equations, maybe absolute value equations or polynomial equations, but a solution is going to be all values of the variable that make the statement true, that makes the equation true, that makes the left side equal to the right side. Now that might be that there's only one solution, and it might be that there's many solutions, but a solution just makes the statement, the equation, true. So when it comes to an equation, there's basically two types of questions. The first question is it a solution? And the second question is, of course, going to be find the solution. So first of all, let's start with the first one. Which of the following are solutions to the equation 2x plus 1 equals x minus 5? Now, if we're just going to find out if x equals 0 is going to be a solution, all we have to do is plug it in and see if it makes it true. So I'm going to take 0 and plug it into our equation everywhere we see x. So 2x plus 1 equals x minus 5. So everywhere that I said x, I plugged in a 0 instead. Now we just go ahead and simplify each side. 2 times 0 is 0. 0 plus 1 is 1. On the right side, 0 minus 5 is negative 5. Is this true? Remember, if it were a solution, it would make the statement true. Is 1 equal to negative 5? It's not. So that means no. It's not a solution. Let's try it again. This time with x equals 6. Let's see if x equals 6 is a solution. Once again, plug it in everywhere that you see x. So 2x plus 1 equals x minus 5. And then simplify. So we go ahead. 2 times 6 is 12. 12 plus 1 is 13. And 6 minus 5 is 1. Is 13 equal to 1? No. So that means x minus 6 is not a solution. Try it again with negative 6. Plug it in. 2 times negative 6 plus 1 equals negative 6 minus 5. Well, 2 times negative 6 is negative 12. Negative 12 plus 1 is negative 11. Negative 6 minus 5 is also negative 11. Are those two things equal? Does negative 11 equal negative 11? Yes. That means the negative 6 is a solution. Now, is it the only one? Well, when it comes to linear equations, yes. Linear equations only have one solution. Now for the second question, solve. And being in Algebra 2, you should remember this from Algebra 1, but let's go through it anyway. How do we solve equations? We got to undo things. You know, get all the x's on one side, get everything else on the other, and then get x's alone. So we do all those maneuverings by undoing the order of operations. So if you remember, the order of operations said to do grouping symbols first, then exponents and roots, then multiply and divide, and then add and subtract. When we're trying to solve, we're going to undo the order of operations. So instead of working down this list, we actually work up this list. And we take care of the adding and subtracting first. So I want to get x alone. How I get x alone is by taking care of the adding and subtracting first. It says plus 9. How do we undo that? By minusing 9. And the other thing about equations, whatever you do to one side, you got to do to the other. So plus 9 minus 9, those guys cancel. And we're left with 4x equals 21 minus 9 is just 12. And then finally, get rid of the 4. That's 4 times x, so we undo multiplication by dividing. Whatever we do to one side, we do to the other. So we're left with just x on the left and 3 on the right. There's our solution. Of course, we could check it by just substituting. 4 times 3 plus 9 equals 21. Well, 12 plus 9 is 21. That equals 21. True statement. So we're good. Solve another one. 7x minus 41 equals 13. So get rid of the minus first by adding. We add 41 to each side. These guys cancel. So we're left with 7x. And on the right side we have 28. Get rid of multiplication by dividing. Divide by 7, divide by 7. These guys cancel. And we're left with x equals 4. A little bit harder. What about when we got fractions in there? Still, get rid of the adding, subtracting first. So subtract 1 from both sides. And we're left with negative 3/5 x equals 3. Now how do we get rid of this fraction? Well, what's happening between the fraction and x? Right here. It's being multiplied. So what we want to do is divide by negative 3/5. And that will make the numerator and the denominator cancel. But dividing by a fraction is the same as multiplying by the reciprocal. So we just multiply by the reciprocal of that fraction, where we flip it over, and that should give us our answer. So we start simplifying this fraction. 3 over 1 times 5 over negative 3. These guys cancel, left with negative 1 over here. 5 divided by negative 1 is negative 5. What about this? 3 times the quantity 5x minus 8 equals negative 2 times the quantity negative x plus 7 minus 12x. Well, heck, is it even linear? If we go back to our definition here, it says a linear equation has to look like this, like ax plus b equals 0. Well, that's a little bit misleading because it really doesn't say that. It says it can be written like that. Can this equation be written like ax plus b equals 0? Well, sure it can. All right? Because as we look through this, we only have x in there. We don't have x and y and z. Or, we don't have multiple variables. And all the x's are only raised to the first power. Remember, that means that we can simplify and we can pull everything over to one side and make it look in that form. But when it does look big and ugly like this, let's simplify each side first. So here we're going to distribute wherever we can. Okay? On the left side, when we distribute, we'll get 15x minus 24. On the right-hand side, we distribute the negative 2. Negative 2 times negative x is positive 2x. And negative 2 times plus 7 is negative 14. And we're still left with that negative 12x on the side. We can continue to simplify this right side by combining like terms. So the left would stay the same. But on the right, we got 2x minus 12x makes negative 10x. Okay. Now we at least got each side simplified. If we're going to continue on to solving it, we want to get all the x's on one side and everything else on the other. So I want to get this negative 10x over to the other side. It doesn't matter. I could bring the 15 over if I wanted, but just the more you work with the equations, the easier you just know which way to bring them. But I want to bring this 10x over to the other side by adding it. That would give me a positive value. All those x's are going to cancel out, and we'll have a positive 25x on the left side. What we're left with on the right side is just negative 14, and everything else cancels out. So continuing on, we want to get that x alone. Get everything else on the other side. So I'm going to add 24 to both sides. That'll leave us with these guys will cancel, and on the left we'll have 25x. And on the right-hand side, negative 14 plus 24 is just 10. The last thing to do is to get rid of that 25. It's multiplying, so to undo it, we have to divide. And those guys will cancel. And we're left with x equals, and then simplify the fraction. Right? 5 goes into both of them. 5 goes up there twice. 5 goes down there 5 times. So our answer is 2/5. And there we go.